So this notes start on page 153. It is section 6, topic 3, graphing quadratic functions using a table. Okay, and let's just start this problem. Suppose you jump into a deep pool of water from a diving platform that is 25 feet above the ground. Your height with respect to time can be modeled by the function h of t equals 25 minus 16t squared, where t is time in seconds. Complete the table below. Okay, so this whole unit is actually pretty easy. It all can be done on a calculator. So that's why I'm going to have my calculator out, and we're just going to start these problems. So first of all I'm going to be doing is these are my inputs, and whatever my answer that I input is going to come out as my output. Okay. Now my inputs are going to be t because it's time. My outputs are going to be how high I have gotten within the time seconds. So the first one, I'm just going to write it out, but in the future we're not going to have to write these out because it's all on the calculator. But I have 25 minus minus 16, and the first input that I'm going to put is 0. So instead of t, I'm going to put 0, and then I'm going to put the square because the 2 is up right here. So it's going to be 0 squared. Okay, and now we got to figure out what that equals. So if I pull out my calculator, I'm going to input this exactly how this says, 25 minus 16 times, because remember, if it's parentheses, that means it's going to be times 0 squared. Okay, I press my equals, and my equals comes out to 25. And that's true because anything times 0 is 0, and the only number left is 25. Okay. Now I'm going to do that with all of these problems now. And again, I can use the calculator. So I take out my calculator and I put 25 minus 16. This time I'm going to put times 0.25, and I'm going to square that number. It's going to equal 24. Okay, and keep going until all of these are done. So the next one is 25 minus 16 times 0.5 squared. I think I pressed that too much because the answer was supposed to be 21. Okay, so that's 21 right here. Okay, next one is going to be 25 minus 16 times 0.75 squared. That didn't come out correctly. Let's try that again. 25 minus 16 times 0.75 squared. And that number should be 16. Okay, now I have 1, so it's going to be 25 minus 16 times 1 squared is 9. And the next one, the last one, 25 minus 16 times 1.25 squared. That answer is 0. Okay, so again, it's not a hard thing. All you have to do is use your calculator and you'll figure out what to do from there. Okay, now let's go ahead and let's graph these. So on one of them, my x-axis, because remember our inputs are going to be our x's, I'm going to have time down here. Okay, and let's measure out time. So I go from time from 0 to 1.25. So let's do 0. Let's go up by 0.25. So this next one, 0.25. Then I have 0.5 for 0.50, 0.75. Okay. Then I have 1, 1.25, 1.50, 1.75, and then we'll be at 2. Okay, and that's about as far as we need to go here. Okay, because I don't go above 2 seconds. Okay, let's go ahead and let's do our elevation. So let's actually go by threes on these ones. So I have 3, 6, 9, 12, 15, 18. Then I have 21, 24, 27, and then I have 30. Okay. Alright, so at 0 seconds, I went 25 feet. Okay, so this is actually going to be my elevation. It's going to be measured in feet. Okay, so at 0 seconds, I went 25 feet. So that point would be about right here. Then I graphed the next one. At 0.25, I went 24 feet. So that's my next one right here. At 0.5 seconds, I went 21 feet, which is right here. At 0.75, I went 16. So that's about right here. Okay. At 1 second, I went 9. And about 1.25, I went all the way to 0. So notice how it's a decrease. Last thing I need to do, connect my dots. Okay, and that's it. That's how you graph using a table. Okay, pause it if you need to pause, rewind if you need to rewind, because I'm going to move on to the next question. Okay, so let's practice. A construction company builds a house on a square-shaped lot of various sizes. The CEO of the company decided to diversify her lots and now has houses built on a rectangular-shaped lots that are 6 feet longer and 4 feet narrower than her square-shaped lots. Okay. Question A says, what is the function that models the size of this rectangular lot relative to the size of the square lot? So first of all, we don't know what our square lots are. So since we don't know how much that is, we're going to mark that as x. Okay. Now she says that this one is 6 feet longer. 6 feet longer. So it's going to be plus 6. Then she says this one, and I'll do this in a different color. This one is going to be 4 feet narrower. So that's going to be a minus 4. Okay. So we have two different ones. One of my sides is going to be x minus 4, because that's the square shaped minus the 4. Then the other one is going to be an x plus 6. Okay. Now this is something we did earlier in the year, where we talked about FOIL and that box method. So I take that first variable and I multiply it to the first variable there. X times x is x squared. Now I take that same variable and I multiply it to the other number. X times 6 is plus 6x. Okay, so now we're done with the first variable. Now we take that number. So I take negative 4 and I multiply that to x. So now I have negative 4x, because negative 4 times x is negative 4x. Now I take negative 4 and I multiply that to 6. Well, negative 4 times 6 is a negative 24. Next thing I want to do is combine like terms. Those like terms are in the middle. Both of these numbers have an x, so let's combine them. 6 minus 4 gives you an answer of x squared plus 2x, because 6 minus 4 is 2, minus 24. Okay. Alright, so now we're done. So let's do part B. Part B says to complete the table below and graph the following function. Okay. So let's complete this table. First of all, I need an x and I need a y. And instead of a y, we're just going to label it as f of x, because f of x is the same thing as y. Now my problem is this up here, what I'm boxing up here. So just like I did before, I'm just going to input some numbers, get an output, and I'm done. Okay. So let's start off with an easy one. Let's go up by 10. So I go 10, 20, 30, 40, and 50. Okay. So now all I need to do is take out my calculator and input this into the equation. So every time I see an X, I'm going to put a 10. Alright, so I'm going to write the first one out and then show you how it's done on the calculator. So the problem says I have an X here, so it's a 10 squared. Because the 10 is my input, my X is right here, there's a square. So I put plus 2, there's another X, so I'm going to put a times 10 here, minus the 24. Now I take out my calculator and I do exactly what the calculator says, or what the problem says. 10 squared plus 2 times 10 minus 24. Okay, and that gives me an answer of 96. So my output would be 96. Okay, let's try 20. Okay, so once again, let's write it out just to clarify. 20 squared plus 2 times, not 10, but 20, sorry, minus 24. And I take out my calculator, put it exactly how it is. 20 squared plus 2 times 20 minus 24. Okay, and now that's 776. Okay, so when I inputted 20, I got 776. So now let's do that for 30. So I have 30 squared plus 2 times 30 minus 24. Okay, take out my calculator, do exactly what I've been doing. 30 squared plus 2 times 30 minus 24. And that gives you 936. Okay, let's move on to number 40. So I put 40 squared plus 2 times 40 minus 24. Okay, now I have 1,656. So 1,656. And last but not least, I have 50. So I do 50 squared plus 2 times 50 minus 24. Gives you a total of 2576. So 2,576. Okay, now I need to label my x's and y's. So my x is actually going to labeled as square lot size, because that's what we're trying to figure out. We're trying to figure out how much the square shaped lot is. So square lot size is the label for that. Okay, my y is going to be how much the rectangular lot is. So how much that new lot that she's trying to build, how much that is. So this is my rectangle lot size. Okay, now these numbers are really big, so let's go up by 100s and we'll go from there. So I have 100 here, 200, 300, 400, 5, 6, 7, 8, 900, and 1,000. Okay, that's 100. Let me add an extra 1 there. Okay, now I know our numbers go above 1,000, and that's fine, but at least we can get the angle of this. Okay, so now this will be 0, of course. My square lot sizes go up by 10s, so let's go up by 5s here. So I have 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. This way, not everything is jumbled up together. I'll put my dots as red. So, we don't have 5 seconds, but we have, we don't have 5 feet, but we have 10 feet. So, if at 10, my number is at 96. So that's about right by 100. Okay, the next number I have is 20, and that was 776. So that number at 20 is about up here. And I'm not looking for accuracy. Most of the time you're going to be seeing this on an answer choice. They'll already graph it for you. Okay, next number was 30, and that was 936. Okay, so at 30 we're at 936, about right here. Okay, now all I need to do is connect my dots. And we're looking at something like this. Okay, when we actually start to graph them on a graphing calculator, stuff like that, you'll start to see a difference in the graph. Okay, this was just basic understanding of how to use a table and how to graph it on a table. Other than that, that's it for this video.